So object-oriented programming is one of the most widespread uses of encapsulation, being able to take some code and some data and to put them together into these things called classes and objects. And one of the most fundamental concepts inside of object-oriented programming is the concept of inheritance. And this is something that you talked about a lot in 159. So the original motivation for this is code reuse, being able to take a parent or a superclass and being able to extend it with new functionality while still being able to use the old functionality by creating a child or a derived or a subclass of that class. In this class, we've talked about pure object-oriented languages versus languages like Java that allow you to have both objects and native data types. We've talked about how methods can be overridden. We'll talk in a little bit about single versus multiple inheritance and about how this illustrates a trade-off between simplicity and power in a programming language. For this video, I want to focus on the difference between static and dynamic dispatch. This is how the runtime chooses which methods to or which actual implementations of methods to run. And then, well, there are other concepts that are important to object-oriented programming, like abstract methods and classes and non-overridable methods. But again, I want to focus on the static versus dynamic dispatch. So here is a code example. And so I want you to think about this for a minute, and I'm going to include some links in the video. So if you look below the video and maybe you have to click Show More, I'm going to include links to places where you can go and run these excerpts online and see the results. But first of all, I want you to just think about this and make a guess as to what it's going to print. So we have two implementations of a function called foo. This is Java code, by the way. So we have two implementations of a function called foo, one which takes an object and prints foo object, and then another which takes a string and prints foo string. We also have a function called bar that takes an object and calls foo on it. So this is important because the only thing that we know about O at the time that we make the call to foo is that it is an object. And so then we have or at least that's the only thing that bar knows. And then in main, we call bar and we pass it a string. So the question is, which of these things prints? So if you have not thought about it, go ahead and pause the video. Maybe go check out the code excerpt and make a guess as to what you think is going to happen. Run the code and then come back here. So if you have done that, you will see that this code excerpt actually prints foo object, and that's because of what I mentioned earlier and hinted at, which is that at this point, the code inside of bar only knows that this is an object, and so is going to call this version of foo. And so this is what's called static dispatch because there's only one place that one version of foo that can be called here because all that we know about O is that it is an object. So what do you think about this code excerpt? So this is slightly different. So now we've introduced some inheritance here. So we have a class A and then we have a class B that extends A. So A is a superclass of B here. And both of them implement the foo function. So A's foo prints A.foo, B's foo prints B.foo. And then we have another function bar, which takes an A, a big A, and calls foo on it. So this is a similar setup here, but now we're using inheritance instead of just calling a method called foo. We are now calling a method called foo that is inside of these classes. So we create an instance of B and we pass that to bar. So again, take a minute and think about what you think this will print and maybe go run the example and then come back. So if you go and do that, you'll find that this example prints b.foo. And this is because Java supports dynamic dispatch. So here, all we know about A is that it is an A at this point, but because Java supports dynamic dispatch for class methods, it will choose which foo is run at runtime based on what this little a actually is. So it could be a big A, but it could also be an instance of class B. And because Java uses dynamic dispatch for this kind of method call, then it will call it will call B's foo instead of A's foo. Incidentally, you can actually override this behavior in Java by adding the static keyword to the definition of these two implementations of foo, and that will force Java to use static binding or static dispatch. Sorry. And so if you go and you run this example, you'll find that it will actually print a.foo rather than b.foo. Okay, so hopefully that's a little bit of an illustration about this notion of dispatch, which you may not have run into before. And so now we want to talk about how dispatch is implemented. So that'll be the next video.